Then I'll go through probably only the first one, which is the abstract factory, which is from the Gang of Four. But the remaining patterns I'll talk about would be patterns that are not really as popular in the .NET platform or on the C# language, but things that can make a huge difference in the way we develop applications. These patterns that I'm going to talk about actually come from the days of Smalltalk. But what's interesting about the .NET platform is we have some interesting things on the platform today that can allow us to do lambda expressions, and also we can pass around blocks of code. So it becomes pretty effective to use these blocks of code to write certain patterns that we normally don't use in C#. But knowing these patterns can help us to design our application very differently. But of course, the first question is, why should we really look at patterns? One of the biggest challenges for software programmers and designers is not knowing which pattern to apply when. And that's incredibly difficult because one of the worst ways to design software is to start hunting for patterns that you can just fit in various places. The application becomes heavyweight, it becomes very difficult to maintain at that point. So in a lot of ways, I use patterns as more of a communication tool. It is where you're explaining your design to somebody and you can say, hey, look, here's what we have done in this pattern, and the pattern names can be very effective to communicate. Now, knowing the patterns can help us to identify a certain structure, so when we are close to a certain particular implementation, we can immediately latch onto a particular pattern, so that can be fairly effective. So again, it's a pretty interesting challenge to really apply patterns in general. But I'm going to go through the patterns and look at some of the different ways in which we can use these patterns. So let's start with what we are very familiar with, which is the abstract factory pattern. And then, of course, I'll talk about various other patterns that we have available to us that we could use. So let's start with the abstract factory. Abstract factory is one of the very first Gang of Four patterns, so most of us should be familiar with it. Now, one of the interesting things about the Gang of Four patterns, as it's called, is based on this book that was written in 1994. And if you remember, the language that was predominant in 1994 was C++. This was way before C# came out. So the examples in the book pretty much focus on how do you build this with C++. But thankfully, C# has some really interesting capabilities. One of them is the meta class called the class, or the type rather, and then we can use the type to build and use that as a built-in factory. So let's look at an example here. Let's say we have a class called the book, and let's say the book is going to have a property to begin with. So very simple, right? So I've got a property on the book. Let's say it's a string, and I'm going to call this as simply a title. So that's pretty simple. And I'm going to keep this very simple in terms of the class itself. And I'm going to also have one more property. Maybe this will tell us the number of pages this particular book has. And I want to be able to create an object of book. Maybe we're developing a web application, and I may get a request to maybe purchase books. I may get a request to purchase CDs. God knows, I may be selling T-shirt, what have you. So I want to write the code in a fairly generic manner. I don't want to be writing code with a lot of different pages doing duplicated work, because that's not a very effective way of writing code, isn't it? So what I'm going to do here, if, for example, I have a class called a CD, and I want to be able to create objects of this and populate it. So once again, well, let's go ahead and put a little toString here so we can actually see what's happening here. So here's the toString method. And all that the toString method is going to do is simply say, string.format, and I'm going to format out, let's say, I want to simply say book, and then I'm going to print out the details of the book, the title and the pages. So basically, in this case, I would print the title of the book and then the pages in the book. So those are my output from the format, and I'm going to just return that right here from this particular call. So in essence, I want to simply create one more class. So I'll just copy and paste this real quick. So here's my CD class, and what I'm going to do in the CD, obviously, this is going to be the CD of the book instead of the book. It's going to have a title, but let's go ahead and give a volume to this particular CD. So just to show that it's a different name we are using. So here's my volume. that I'm going to use in the code. Okay, so that is my class. Now I want to create an object of this and use it in my code. So how would I go about doing that? So let's look at an example of that. First of all, I'm going to create, let's take baby steps. Let's take a method. This is going to create an object. We'll call it as create. And this is going to take a class name as a parameter. And we'll come back and implement this in just a minute. Fortunately, there's quite a bit of interesting built-in types available to us that we could use. So that's what we're going to do here. We're going to simply use the built-in capability to create the object. The factory is given to us. So what do I want to create here? I want to call the create method, and I want to send to it a string. And in this case, the string I'm going to send, my namespace is called patterns. So patterns.book. Let's start with that. So how do I create a book from here? So what I'm going to do is, given the class name, I can say type, for example, for the type itself equals type dot, and I could ask get type and provide the class name to it. So this gives us the meta class in .NET, right? So you don't have to build a hierarchy of classes for factories. You can simply use that very effectively. And then once I get the type object, I could say activator dot create instance. So I could say create instance, and that would use the default constructor, and I'm going to simply give the type to it. And then that's going to return to me an instance. So I'm going to say instance equals. So now that I created the instance on hand, I can simply return the instance. We need to still populate the instance, but let's wait for that. That's baby steps. We'll take a couple of steps to get to it. So if I just run this code real quick, let's see what it tells us. Make sure I clear out the errors here. So in this case, already contains a definition of book. Oh, of course, I forgot to change this one, didn't I? So CD, there we go. So, okay, it says book 0, not a very helpful output, but it's going to support us the title and the pages to print. We'll get to that in a second. But similarly, what I could do is I could create an object of the CD. But notice how the same code called create is going to, on one hand, create a book. On the other hand, it's going to create a CD. So that was easy, right, so far. But what I need to do next is to populate the data. You know, if you're building a web application, most likely the data is coming from maybe a web page or what have you. So what do you think would be a good place to put that in a very generic way? Can you think of something? Like a dictionary, right? Because a dictionary would be a name-value pair, and you can just populate it with the dictionary, correct? So notice what I'm going to do. I'm going to go back to this create method. I'm going to add one more parameter here, and the parameter I'm going to add here is dictionary, and the dictionary is going to take a string because you want to know the name of the property, and the name of the property is going to be a string, and I'm going to specify object, which is basically the value that I'm going to get for this. So I'm going to say values over here. So now that I have a name value pair, I can populate with it. We'll come back to that in a minute and see how we can populate it. But the first part here is to send the data that we need to send. So I'm going to say here, new dictionary, and in this case, the string and name. Now I can simply send him a name value pair, basically, in this case. So I could send him maybe a list of names and values. So for example, I would say title, for example. So I could say title, and then I could send him a value for the title. What would that be? For example, that could be some title, so whatever the title I want it to be. And then I could send maybe pages, and then let's say 100 pages in this book. We could specify certain values, and we'll get back to the syntax in just a second. So basically we can send a set of values and pair of values and into here and send these name value pair. Similarly, I could come down and pass a dictionary back over here to the CD also, right? So basically creating a dictionary object, and once we pass the dictionary, we can figure out how to populate it on the other side. So that could be pretty simple to do. That shouldn't be too hard at all to do. So let's see how we could send this over to this one here. So this is going to be my abstract factory. Let me pull in my little code here. So basically it's a comma separation. Okay, fine. So basically this is going to be a comma separation of these values, and that's all I'm going to repeat over here for the next one also, right? So basically in this case, this is going to be the CD. So let's go ahead and change this to a CD. And this is going to be the title, some CD title. And then this is going to be volume, let's say volume 2. So we could say volume over here, right? So let's make sure this is accepting it. Add is, so it's having a syntax issue here. Let's go ahead and fix it. Did I say new? Yeah, I create a new dictionary. So new dictionary of the object. Oh, two parentheses right there. So one to say this is the property itself. So I need to embed that within that context. So let's see if that's helping him to get through it. So let me just grab this here. Name value pairs, basically it's a tuple. So let's go ahead and modify that. So this is one value, and then this is the other value. Just noting the syntax over here. So similarly, I need to pass in a name and value. So that's the title and the CD title. And then we are sending the dictionary and then the volume itself. There we go. So what's happening here? We need to populate. So that's the last part, right? So what do I do here? I'm going to go back to the create method. So we can use the for each. And we could say we have an entry. So we could say entry in values. And then we need to populate this, right? So we got one value at a time. But how do I get the values and populate it? Well, we again can use reflection to get around this, right? So type dot get property, and the get property is going to be entry dot key. So that uses the property name. We could call set value on it, and the value is going to be set on the instance that we created. And the value itself we want to set is the entry's value property, and there's no index for it, so send a null to it. So that basically loops through the values in the collection and then populates the values one at a time, as you can see right there. So in this case, it should be able to populate the book and the CD pretty easily, right? So very simple to use a factory. We could dynamically populate the properties using reflection. So abstract factory becomes very trivial to build. So that's one example from the gang of 4 patterns. But I want to go back to something else. We normally build applications with other mechanisms. Let's say for a minute we have a class called mailer. And the mailer class, so this is going to be the Cascade pattern I'm going to talk about. So the mailer has a function, let's say public void 2, which takes a 2 address as a parameter. And I'm not going to implement any code in there, just to show you the interface at this point. And then I'm going to have a from, which is going to take from address. And then I'm going to have maybe a subject, which is going to take a subject as a parameter. And then, of course, 2 last things, a message, which is going to take a message as a parameter. And then finally, a send method, which is going to really send the email. So how would you use this? So way to use this would be something like this, right? You would say mailer equals new mailer, and mailer dot from maybe builder at .com, and it's going to send the mail. So I'll say mailer dot to, and it could send it to me. And then it would send it to the subject. So mailer dot subject, whatever subject it is. And then mailer dot message, some message, whatever that message is. And then finally mailer dot send. Looks familiar, right? Everybody has written at some point code like this, right? What's wrong with this code? You should have cried the last time you wrote code like that. What's wrong with that? It's duplication, right? You had to say mailer, 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 mailer so many times. If you're talking to somebody and they say that, you will slap them, right? Because there's no context in this code. It's boring. You keep repeating the word mailer so many times. There's another problem. At line number 27, you have a question. What do you do with the mailer object? Do you throw it away? Can you call methods on it one more time? Can you reuse it? And what is the normal answer for those questions? You say, go read the damn documentation, right? It's got to be a better way to do this, right? So how do you really avoid this repeated calls and build a context into it? So this is where the cascade pattern comes in. What the cascade pattern says is, why don't we chain these methods and cascade them through so that we don't have to keep calling this mailer several times over. So notice what I'm going to do. I'm going to break away from some conventions. So I go back to this code, and I'm going to take these 4 methods, and I'm going to highlight these 4 methods, and rather than returning a void, I'm going to say mailer from each one of them. So basically, each of these methods now are going to return a mailer. So what does that allow us to do? It allows us to cascade method calls. The send method doesn't take any parameter. Sorry, it doesn't return anything. It's a void method. And of course, it doesn't take any parameters in this case. But all the other methods are returning mailer. So what I can do here, you will obviously have some code, which we're not interested here. But at the very end of that code, you're going to return the current value, this object, right? So in all these methods, you're going to basically return the current object. That's all you're doing. So what does this do to us? Now notice what I could do now. I could go back to this code. First of all, I don't need this reference anymore. So I can just start with new mailer. And at the very end, I would not have the semicolon. But instead, what I'm going to do is simply go back to these and remove all these mailers from here. So now notice how you removed that duplicated, redundant call to mailer. In other words, you have a built-in context. Nicely, this object flows through, right? So new mailer, and on the mailer, you're calling the from, and then to the result of the from, you're calling the to, and the result of the to, you're calling the subject. To the result of the subject, you're calling the message, and the result of the message, you're calling the send, and now you have cascaded those calls. What's even interesting here is, while these methods are returning a mailer, it doesn't have to. Mailer could be an interface or an abstract base class, and some of these methods may be returning a concrete type. So you could be dealing with more a specialized type along the way. Or it could be even different. It doesn't even have to be returning a mailer. It could be returning something arbitrarily very different. And all of a sudden, in the middle of the chain, you have switched on to dealing with a different type. Well, how do you know what to do? Well, that depends on the context, your domain, your application. Whatever that you're building decides what you're going to do with it. So that is an example of how you could use a cascade pattern to build your application. So it kind of flows naturally, nicely well. And so what did we do, though? What we did was we violated certain conventions. And it's a normal convention that methods that do some work return a void. Well, we kind of deviated from that convention and started returning. So the mutators do some work, and then they return an object on which you can build further calls down the chain. And so that is basically what a cascade pattern allows us to do. And so once we do this, it becomes very compelling API and becomes a lot more fluent to build things with it. You can push this to a lot more extent if the language was a little bit more flexible. But with language like C#, this is probably how much you can get to in terms of the fluency of these calls, in terms of the cascade pattern. So that is basically the cascade pattern. Let's talk about the next thing I want to show here, which is something called a pluggable behavior. And so let's see what pluggable behavior really is. Let's say you are at work and one of your colleagues says, hey, I have a list of numbers, and I want you to total those numbers. Okay, you say, no problem, I can write a function to do that, right? So let's look at an example. So I want to write a function and total values. And what's this function going to take? It's going to take some values as parameter. So what is this values? I could say values as an array equals new integer. And let's just say 1, 2, 3, 4, 5, and 6 are my values that I want to call into this. So pretty simple, right? So you're going to call these total values. What does the function total values look like? So I'm going to say, integer total values, and this simply takes a values as a parameter, and all that I'm going to do here is define total equals 0, and then return the total when we are done. And in between, I'm going to simply take the values. So for each, let's say value in values, and very simple, total plus equals value, right? That was easy. So you got that done, and run the code, and it totals up all those values, tells us the value is 21. So you are done, and you are about to go home when your colleague says, but I need one more function from you. Not only do I want to total these values, I also want to total only even numbers from this list. He doesn't want that method instead of this. He wants both the methods. So not only does he want a total values, he also wants one more function, which is total even values, right? So what he wants is a function called total even values. Well, that function doesn't exist at the moment. How do you write it? You think about this for a few minutes, and you look at your watch, it's getting late, you really want to go watch that match, right? So you look at this for a few minutes, and then you convince yourselves there's a reason God created copy and paste, right? I mean, this got to have some use, right? There's got to be some use. So you copy that, and you paste it. Just for a minute, there was a guilt, and you quietly ignore it, right? And then you say total even values, and then you simply say if value mod 2 is equal to 0, then do the total. That's done, and you're about to leave home when your colleague says, but I need one more function. And the function he wants this time is total odd values. And you know it's very wrong to copy again, but the forces of match is in front of you. You say, fine, total odd values, and you tell yourself, I will fix this soon after the match, right? So you know this is wrong, but you'll fix it. And it works, and this time you leave quietly without telling your colleague. Well, guess what happened? You duplicated it 3 times, right? And that evening, you're sitting there, and your guilt just overcomes you. You say, I'm going to fix it. And you open the computer. That's when your friends come over, and they ask you what you do. And you say, well, I'm just fixing some code, but what's up? They say, no, we want to look at what code you're fixing. And they lean over your computer, and they are shocked. They look at you and say, this is what you do at work? They no longer return your phone calls. They don't want to hang out with you anymore. They go to some other friend's place to watch match. How sad life becomes, right? So no, you should never write code like this. So what do? How do you remove duplication like this? Well, our general approach would be, oh, let's create a class. Let's create an interface. Let's create an abstraction. Well, the problem with those approaches, it's very heavyweight. Takes a lot of time and effort and more code to maintain. But we don't have to do all of that. What we're going to use here is a pattern called the strategy pattern. You say, hey, wait a minute, I know strategy pattern back from the Gang of 4 days. Well, it's a little different here. The strategy pattern of the Gang of 4 uses more of a class-based approach. We're going to use a very different approach here. We're going to use a block of code approach. Let me show you how. So the very first thing we're going to do here is we're going to remove this duplication altogether. So, but before we do that, if you notice, if you ignore the function name for a minute, the only difference, in fact, a small change here, if I were to put if true over here, then you clearly see the difference, right? In all these 3 methods, ignoring the name of the method for a minute, the only thing that's different is what's in the parentheses within the if, right? So if you can externalize just that block of code which is in the parentheses into a separate function, then you can remove the duplication very well, isn't it? So notice what I'm going to do now. I'm going to go back to this code, get rid of these duplicated code, change this code that we have up here into total selected values. Well, we don't know what selection it is yet, but the first parameter we are sending is the values. but I'm going to send one more parameter to this. But there is a difference. The first parameter is an object, but the second parameter I'm going to send, guess what it's going to be? What was that? A function, that's correct. I'm going to send a func. So we can externalize and send a func to it. So what I'm going to do here is to send a func object, and the func object says, well, if you really look at the code within the parentheses, if you were to treat that only the code in the parentheses as a separate function, what do you think is the input to that function? That's correct. It's got to be an integer. So I'm going to send an integer, and what do you think is the result? A Boolean. There you go. So my function is the selector I'm going to send. Pretty darn simple, isn't it? Right? You're basically externalizing this and saying, I'm going to send a function object, and this is going to take an integer and a Boolean, and that is basically my selector. So here I'll say, hey, selector, if you accept the value I sent to you, and if you return a Boolean true, I will total, otherwise I'll just reject it. So now we have completely generalized this function for this particular totaling operation. But notice we didn't have to go out and write classes and abstraction and all those good stuff, right? Just works this way. Now, how do I use this? So let's take baby steps one more time. Let's remove these two. We'll come back to this. I'll go back here and say total selected values, which is what we want to call here, right? And the first one is the values. The second one is going to be a function object itself. So this is going to take an integer. So this is going to be a value it takes. And what does he do with the value that he takes? He's going to return from here whether, just the true, right? Because we're going to accept all the values that are given to us. That's what we want to do at this point. Because remember, the first execution was totaling all the numbers, right? So the function simply returns a true. You remember what the total was before? 21, right? It's still the same. But now, notice what happens. If I want to total the values but only even numbers, all that I have to do here is say value is even. So basically, since we externalized it, we're not writing any more functions. And now I want to total only odd numbers. I can simply say this is not equal to 0. Again, we're not writing any more functions. That's looking at the odd numbers. In fact, this is more extensible. If I only want to total numbers greater than 4, all that I'm going to do here is simply say that the value is greater than 4, and now the function is totaling all the values greater than 4. So you can tell your colleague to go write it himself. You don't have to be writing there more and more code. I think that was a question here. Anybody had a question? No? This is basically a predicate. That's what you're doing, right? It's just a term that you give. Repeat that? Right. Well, it's just a term. What you call it doesn't matter, right? But the concept is essentially something general enough for you to use, and you can pass it around. So that is the beauty of this, is that, so this is basically called the pluggable behavior, and how you can pass that around. This is basically due to the lambda expressions and then extensions from it, it becomes a lot more easier to use. Yep. You have the right not to agree. Yes. And what's your problem?
Ultimately, comparison, I think, on behalf of you, right?
Correct.
It's not really, it is just a synthetical tool, right?
Well, the point is this. When you are hired to get your work done, you could spend your time writing a lot of code or use tools that do the work under the hood. And who is going to come out ahead winning? By you writing all the code yourself and maintaining it, or using a tool more effective so it hides the complexity behind the scenes so you can get your work done and go home. So you decide that. So what does the executor on method pattern do? Now let's say for a minute that I want to create a resource, and so I have a class called resource. And the resource is going to use some expensive resource under the hood. So what am I going to do? I'm going to have, let's say, a constructor for the resource. So here's my constructor. And what am I going to do in the constructor? Let's say creating. And I'm going to have some operation. So let's say my operation is called op1. And all that my operation does, simply in this case, is it says op1. Okay. Similarly, I'm going to put an op2. So what do I do with the op2? And so right there's my op2 that I'm going to create. I have a method to clean up. So I say resource, and here I'm going to do the cleanup. So I'm going to say cleanup expensive resource. And I want to make sure I clean this up very quickly, right? So let's give it a try. So I'm going to create a block of code, and I'm going to create a resource equals new resource. And I'm called the operation on it, so op1. And again, call this one op2. And here, let's say, out of the block. So if I run this code, notice how it created the object called op1 and op2, printed out of the block, and then it cleaned the resource at the very end. So in other words, I really would like it to clean it up right here, but it didn't. It waited until much later time to clean it up. So how do I make sure it cleans it up here? Any ideas? Using, right? So what you would say is, hey, why don't you use using? So notice what you would do. You would first have to go, well, actually we'll come back to that in a second. Let's go back here and say, hey, I don't want to create the resource here. I'm going to say using and resource equals new resource, right? So that's what you would do. But it's complaining why? Because if you want to use using, you have to implement iDisposable, right? So what do? You go up here and you say iDisposable. So you implement iDisposable. And since you implemented iDisposable, you're going to implement that interface. And what you can do here is maybe you can write a common method that you're going to call. So I'm going to say private void cleanup. And I'm going to call the cleanup method from here. So basically in here, I could simply say call the cleanup. And in the cleanup method is where I'll put the code that's going to do the real cleanup. And then in the dispose method, what I can do is I could say call the cleanup method. And then you would say gc.suppress finalize. So then, in this particular case, this. So in this case, what's going to happen? It cleans up, and then it comes out of the block. What do you think of this idea? Like it? Not like it? It's okay? You got to have some opinion. What was that? You need to show me where you are, because I hear you better when I see you. Who's talking? Yeah, what are you saying? That's correct. So first of all, do you like it, or you're not sure where it's like, it's lukewarm? You don't like it, okay? I'm with you. I don't like it. This sucks, right? And I don't like it because what you pointed out, you had to implement. There's more code you had to write, certainly, right? But after all of this effort, there is still no guarantee, right? What happens if a programmer comes down here and doesn't use the using? Because using is not a required call. You cannot force the programmer to use using, right? So they could still come and say resource equals new resource, and you're back to square one. So that was a defeat, right? After putting all that effort, you still expect the programmer to do the right thing. And if you're expecting that, don't expect that from me. I'm not going to do the right thing. Half the time I'll forget this, right? And that's why I need tools to support me rather than me having to remember every time. Well, we're going to fix that problem. We're going to force the programmer to do the right thing. And it will make it sure in a way that the programmer cannot write the code any other way. That would be cool, isn't it? So let's see how we can do that. So what I'm going to do first of all is I'm going to go back over here and get rid of all that added complexity we added. That's gone. iDisposable is gone. So I'm not going to have the iDisposable implementation method here, dispose method. That's gone. So back to square one. So I'm going to get rid of this using also. We haven't fixed the problem yet. I just went back to the code I had before. But notice what I'm going to do. The first thing I'm going to do is I'm going to make the constructor protected. What's that going to do? You can create an object. So notice the new resource fails. Now as a programmer, you're going to look at this and say, what? How do I use this object if I cannot create it, right? So now it forces you to go a certain path. So how do I really make this work now? So notice what I'm going to do. I made that protected, and now what I will do is I'm going to write a static method. So public static, and this is going to be void, and the method name is called use, or call it whatever you want to, right? And what is that going to take? It is going to take a function. This function is going to take a resource as a parameter, and it's not going to return anything back to us. So I don't need to use a function for that. I'll use an action which takes a resource. And let's say this is block of code I want to send to him. But notice what I'm going to do in this code. I'm going to create a resource equals new resource. So I am creating a resource object right there in my code. In fact, because I'm doing this myself, I will have the discipline to remember to do this once. I can use the using to create this, right? So I'm going to use the using to create this resource. And now we are within the block of code within the using. So we are saying using, or if I don't want to do that, I could implement the disposable if I want to, or we could have the discipline. We could say try, let's make this simple, and I'm going to create the resource myself on hand without using the iDisposable, but you have the option to use it if you want to. And then I'm going to say finally, because there could be an exception, and finally when you get back, I'm going to say resource dot and cleanup to perform the cleanup, right? Notice how we took on the responsibility to create the resource and to clean it up within the bounds of our code itself. And right in the middle, in the try block, in the safety haven of the try block, I'm going to yield my control to the block. And I'm going to say, hey block, accept the resource and do your work. Right? So I write this code as a use block. So now notice what's going to happen. Well, this code doesn't work, obviously, so what am I going to do? So what I'm going to do instead of this is I'm going to say over here, in this case, let's get rid of all of that. So I'm going to simply say resource dot use, and I'm going to send him a block of code that takes a resource. And what's he going to do in the block of code? That's our business, whatever we want to do. So what am I going to do here? Resource dot op1, whatever operation I want to perform, resource dot op2, or any combination of those calls I can make. And when we are done, we simply come out of it. But notice in this case, it's going to clean the resource up for us automatically. So what's happening here? We call the resource use. Use method creates a resource for us separately right here. And once it does that, it calls the block of code. And the block of code is called right here. It allows us to do whatever operation we want to do with it. When we return from this code, we're going to go back to this code. In the finally block, we clean up the resource. And we have said we are done. So now we don't have to do any specific external cleanup because that's taken care, right? So now you can see automatic cleanup happening. So this is a very common pattern from the Smalltalk days. This is called the execute around method pattern. The beauty of this is you don't have to think twice. You are forced to follow a certain way of using the object. Unlike the using, you can say, oops, I forgot to use the using, right? Well, you cannot forget here because you're forced. That's the only way you can create this object and use it. If you try to use the constructor, it'll give you a compilation error. So you're not able to use the constructor You're forced down this path, and you have to use this. So that is basically the execute around method pattern. This pattern is pretty powerful. We can use it in a number of other cases. Any questions or comments on the pattern before we go to the next one? Yeah. If you return an object from where?
From your block.
You could return the object through the use method, right? Nothing stops you from doing that.
The point is, you already call a cleanup. How can I return an object which is called?
Well, remember, you got to use your common sense in this case. The main purpose is to have a very well-bounded cleanup.
Now, right? It's a very specific situation.
No. The whole point is you want a very well-bounded cleanup of the object.
That is accepted, but
That is when you use it.
yeah, point is you can't use everywhere, right?
Oh, okay. What is it that you can use everywhere?
So say, for example,
Tell me what you can use everywhere.
to both the case, okay?
Hang on. What is it that you can use everywhere?
So I want these guys to be done for my replacement.
That's not what a pattern is. A pattern,
Replace the dispose pattern around with your around a method, right?
you can't, right? When you use using, the using block is going to kill your object also.
Right.
You can't return from that block, right?
Right. So the same issue is still there.
And the point is,
The point is, we can't do that, right?
you need to understand what you're solving. I don't think you're understanding what the problem is. So I can't help you. Okay? So the point is, you have a very bounded cleanup of your object. But the problem with that is, your using doesn't guarantee its use. So if you want to use using, but if you want to force the user of your class to use the using block, there's no way to do that. What this gives you is a very well-forced boundary to clean up the object. If that is what you want to use this pattern. If you don't want to use that, don't use the pattern, right? That's what a pattern is. A pattern solves a particular problem, and you need to use it to solve that problem. And the minute you try to make a pattern to do everything you want it to do, it no longer is an effective pattern. So that's why it's important to understand what problem we are trying to solve. So don't try to make a pattern do what it is not intended to do. So if you really want a bounded control on the cleanup of your object, this solves your problem. If that is not your problem, don't use the solution. I'm not here to give you a solution that works for everything, because there's no such thing. So it's important to know what the problem is and use it for that purpose. So any other questions? Yep. This has no consequence of threading because we're not launching other threads. And multi-threading usually is a pain in the neck. So if you're going to launch other threads and pass this around, you will have severe consequences. So this only makes sense when you're in a single-threaded situation. You don't want to launch other threads from this code and pass it around, because generally when you're dealing with threads, there are other issues that you can't just deal with. So absolutely. So you want to really be constrained within a thread here.
So can we use this pattern if you want that block of code to execute always in a different thread?
You could, but that's really not the intent. If you really are interested in multiple threads being dealt with, there are a lot better solutions available on the Microsoft platform today. For example, one of them is this interesting concept called the mailbox. So F# really promotes that quite effectively for you to use, but you can use that from C# as well. So you could create a mailbox. And the nice thing about mailbox is, some of us may remember back in time when you had COM, you had the so-called STA, single-threaded apartments. So in a very similar manner, you could create a mailbox, and then the messages you throw on the mailbox executes its own thread, and then you can get the response back. So you really want to go towards something like that, and this wouldn't be a good solution for that. This is really more for, hey, I've got a file that I want to open, but I want to close the file automatically. Or I have some other resource I want to open, but I want to close it automatically. The place where we used this was, we had an application where we had to do quite a bit of transaction boundaries. And our programmers would start transactions, but then they have to remember explicitly to abort the transaction or to commit it. So we said, hey, why don't we create a transaction object using the execute around method pattern? So you said transaction run in, and then you put your block of code. And it nicely runs in the block of code, and the minute it leaves the block of code, it checks the status and either commits the transaction or aborts it. So now we don't have to worry about long-running transactions or transaction leaking out. It was a very clear boundary that we were able to use. So again, that's where the real benefit of this is. that you want to use it. Yep?
If I have multiple constructors,
Yes.
in that case, I'll have to also have multiple use.
Fair enough, right? So if you have multiple constructors, so instead of having constructors, really, you are having the use method. So the use method becomes your factory method in a lot of ways, right? And then it creates the object for you using the internal state that it needs to set up. So you would have multiple overloaded use methods rather than constructors.
Instead, can I write that use code in the constructor as well?
You can't, because if you do that, then the users would have to create an object. Then you end up with the problem of, oh, they created the object, who's going to kill it? So, that's the problem.
Can I call the cleanup in this constructor as well?
I would say try it. That's the best way to deal with patterns, right? This is a wonderful thing. You get all these wonderful ideas, and when you try it, you will realize that there are limitations to doing it. And then you realize, okay, this is the more structured approach to do it, and then there's a reason why it falls into that. But, the best thing to do about design is to try it, right? There's no point in talking about it in hypothetical terms. Try the code. It either works or it doesn't. That's the way to learn. Yeah. Well, where can you use this? The beauty of this is, let's say you have an exception test. I'm a huge fan of unit testing. And let's say you have an exception test you want to write. So one of the things you do in exception test, I'm not going to write the real test here, but just to show you, is let's say you have a public void test. So you would say test over here. And if you're, depending on the framework that you're using, you could say test or test method, what have you. And let's say some method, exception. So what do you do here? You could say something like this. You could say try, right? And in the try block, you could call, let's say you're going to say my object equals new my object. Maybe you have to do a setup on this, some setup to get the object running. Then you could say object dot some method. And maybe this is a wrong setup. So you're expecting an exception to be thrown here. So you could say catch, and then you could say my exception, EX. And then if this exception is thrown, life is good, right? If the exception is not thrown, you would want to say assert fail, and then you would specify whatever the failure message is. So if you have written exception tests, this is kind of the format you're going to follow, right? So what do? You create your object, maybe in the setup method or whatever, it doesn't matter. And then you do some other work. Then you have a try block. You call your method in it. And then you do an assert fail. Because if this method doesn't throw the exception, you want that fail to be killing your test and failing it. And then in the catch block, you're saying, aha, if the exception was thrown, and if that exception is this exception, I want to handle it, right? That's what you're doing. What's wrong with this? What's wrong with this? It's a lot of code, right? It's verbose. And very few of us want to sit there and write more and more and more code, because that's boring. You want this to be concise. So what does some of the testing frameworks do? They give you an option, right? They say, hey, why not this? Expected exception. And then you could say my exception type, whatever the syntax is, don't worry about it right now. Then you don't need the try block. You could simply say, some object, some method. You don't have to do any of these. So the nice thing about this is, it is very concise, right? Well, what's wrong with that? Yeah, well, the problem, you're right, is this test doesn't say that some method is throwing that exception. It is possible that this method threw the exception too, and the test would end up passing for the wrong reason. That's why I don't like this at all. In fact, this was deprecated in NUnit. So you can't even do this in NUnit anymore. But if you're using the Microsoft testing framework, for example, and you want to write the exception test, then it becomes verbose. So there is an alternative here. What could you do? What you can do instead is we could use the execute around method pattern. Like how? So you say this is a test, and then you come down here. You could create a test helper. So you could say test helper, and you could say my exception, whatever that exception is, and then you could say something like run or should fail. You could say that. And then you could specify here a little action which is going to execute this method for you. So you would say some method right there, and then this would be the end of the should fail. So you know how to write this helper, right? How would you write it? The should fail method is going to take as a parameter an action, like the example you just saw a few minutes ago, right? So the should fail method takes an action, and in the action method, you would write that verbose try and finally code. So you will take the hit once and write that verbose code. In fact, what's the beauty of this is you could even return the exception that you receive from within this code. And as a result, you could even say here, exception EX equals, and then you could even examine the exception right here if you want to. But the beauty of this is it really gives you a granularity and says that's exactly what I want, where I want the exception to be, and I can catch it. So that is one other application of the execute around method pattern, where it says I'm going to give you this code I want to run, and I'm going to say that code runs in this block, and if this code doesn't throw the exception, I will fail the test. If it throws the exception of that kind specifically, then I will capture it and give it to you optionally. You can use it and then do much further examination if you want to. So that is the power of the pattern. You can use it. So this really emerges from the good old small talk patterns, but you can apply to various other things. So what I did here was to show you some of the somewhat of unconventional patterns in C#. Sure, you can go back and use the gang of 4 patterns. Definitely you can do it. But you can think a little bit further and say, hey, I can use blocks of code and pass them around. Then I can structure my code very differently. And again, the beauty of this is you could do this today in C# if you want to, as you just saw, and benefit from this. Hope that helps you. Thank you.